Welcome to my session, Continuous Testing with Molecule, Ansible, and GitHub Actions. There's a lot of reasons why you might want to use continuous integration or CI, but the main thing that I use it for is to make sure that all of my projects that I maintain and that I contribute to are always in a state where they work. It's surprising sometimes when I look around to see how many projects are out there that don't have any kind of integration testing. And a lot of times they'll ship a release and that release ends up breaking some things. And once the release is out in the wild and it starts breaking things, it all of a sudden is an emergency to fix it. And then you end up pushing through an emergency fix. And that fix might break something else, but you don't know about it, but it's so important to push it out that you do, and it just kind of ends up in a cycle, and you kind of get defeated, and your team spends a lot more time working on fixing bugs than delivering any new features or improvements. And so I have on this slide the main purpose in my mind of having continuous integration in a way that runs integration tests on a continuous and regular cycle, like weekly or daily, or even more frequently than daily in some cases. Anyways, this quote is from David Farley, and it says, "The earlier you catch defects, the cheaper they are to fix." And as I said, it can kind of turn into a cascade of failures if you start getting into a cycle where your defects get worse and worse and worse and continue piling on, and you never have the time to be able to fix them and make them stay fixed. Who am I, though? I am Jeff Geerling, and I have been an Ansible user since 2012. A lot of people in the Ansible community might already know some of my work through my username Geerling Guy, because I have a lot of popular roles and content on Ansible Galaxy. I also wrote a book called Ansible for DevOps. You may or may not have heard of it, and I'm writing another book called Ansible for Kubernetes. So I have spent a lot of time thinking about maintenance and maintainability. Just a little story on Ansible for DevOps. I started writing that book in 2014, and I decided at that time to build a GitHub repository for the book with all the examples in the book, and I have always had tests running on it. So every time I make changes to the books, I increase the test coverage and make sure that all of the primary things like installing software and performing tests that make sure it's working is always being tested, and that runs weekly, and that's been the case for five years now. And a lot of times that alerts me to the fact that something is going to break soon in some of my other work. So it's kind of a good canary project for all my other projects too. But I've always had this continuous integration in that repository, and it's made it so much easier for me to keep the book updated. And I just published a second edition last month, so it would be great if you are interested in learning more about Ansible. That book is a great introduction and also has some great examples for real-world use cases. And Ansible for Kubernetes, I'm about halfway through writing it, and I'm working on that feverishly right now. So if you do Kubernetes work or OpenShift work and want to automate it with Ansible, that's a good option for you. But the main reason why I think I'm pretty good with continuous integration and using it to make projects better is the fact that I am an open source software maintainer, and I have 200 plus projects in my GitHub account, including some private projects that I use that integrates other projects that are public and open source. And across my projects, there are 27,000 stars on GitHub and 14,000 forks, meaning a lot of people are using this stuff. A lot of people are contributing back, and a lot of people are getting value out of it and extending it further, which is awesome. I always encourage people to fork my work if they enjoy it and get something out of it and need to make an improvement. I don't always accept contributions back, because sometimes it's something that I know is going to cause more maintenance overhead than it's worth for me if I'm not using that feature. But I've done this for years now, and the scope of my work has grown and grown. And without continuous integration, there's no possible way that I could keep up with all these projects and with all the contributions and things. And I don't say that I'm perfect at it anyways. There's some projects I don't spend as much time going through the issue queues and responding and things. But that's why I encourage people to fork my work and take the open source work forward and improve it for themselves too. So this particular presentation is based on an example that can be found in Chapter 13 of Ansible for DevOps. And as I mentioned, that's the book that I wrote. You can actually purchase it at AnsibleForDevOps.com, but you don't need to buy it to follow this particular example. If you go to that website and scroll down, at the bottom there's a link to the GitHub Examples repository. And this example is in the molecule directory of that repository. So if you want to follow along, you can do that. Or if you want to check it out later after this presentation is over, be my guest. But that is where this is from, and Chapter 13 goes into much more detail than we'll get into in this presentation. So I have a playbook. This is a pretty simple Ansible playbook, one of the simplest playbooks that I would write, but the funny thing is I have a couple playbooks that I use for production applications that are basically this, where I need to set up a static web server or build a container that's running Apache and has a web page inside of it. And this playbook is really simple. It runs on all the hosts that it's given in the inventory. It has one handler to restart Apache, and it has 3 tasks. One makes sure that Apache is installed, one copies a web page into the default Apache directory, and the last one makes sure that Apache is actually running. So if you are eagle-eyed, you might notice that this playbook is written only for Red Hat or CentOS or Fedora, in the fact that it uses HTTPD. If you were writing this for Ubuntu or Debian or one of those flavors, you would call the package name Apache 2 instead of HTTPD. So you can actually make this playbook cross-platform very easily, and in fact, in the book, I do that. I just didn't want to do that in this presentation because we don't have a ton of time to cover all that, and it would make the text a little bit smaller, which makes it harder to read, and that would be sad. So anyways, this is our playbook. It's a pretty simple playbook, and if you run it on any CentOS 7 or 8 or Fedora, I don't remember what versions it works on, but most of the modern versions of Fedora, CentOS, or Red Hat, it should work out of the box. And you should end up with a web page being served that says, "Hello world," very friendly and happy. So we want to be able to test that playbook and make sure that that playbook actually does what it says it does. We want to make sure that it installs Apache, and when the playbook is finished, we want to make sure it's serving that "Hello world" page. So we're going to use a tool called Molecule, and Molecule is built as a testing and development tool for Ansible. And originally it was built just for Ansible roles, but you can use it for Ansible playbooks, any kind of playbook. It doesn't have to be a role. I use Molecule to test my collections, my playbooks, and my roles. So the first thing that we need to do to get Molecule working is to install it, and I use Python 3, so I say pip3 install Molecule and then square brackets Docker, and that's going to make sure that Molecule installs all the proper extensions to be able to integrate with Docker. You can also install different plugins with Molecule to use it with different kinds of platforms, but Docker is very universal and works in CI, on my computer, and anywhere else that I would ever want to run things. So I'll stick with Docker, but you could use Podman or something else too. The next step is you're going to create a default scenario, and Molecule uses scenarios to kind of have different test environments that do different things. So if you had a really complicated playbook and it did 5 different types of servers, you might want to have a different scenario for each server, but for most of my playbooks, I just have one scenario, and this will create a scenario called default, and default is the default scenario that's used if you just run Molecule commands. So we're going to create that scenario, and then we're going to make a few modifications to have it run this playbook. Instead of out of the box, it usually is set up for a role or a collection. We're going to make a couple changes to make it so it runs the playbook that we saved, and I save that playbook as main.yaml. And in the same directory, we run these 2 commands. We have a Molecule default directory, and I'm going to modify the molecule.yaml file and make a few changes. One thing is I like to lint my Ansible YAML files, and I like to run 2 lints on it. And linting is basically making sure that the file itself doesn't have any syntax errors, and it doesn't mean that it's going to work. We have to do an integration test to do that, but it does make sure that we're not doing anything really wrong, like having the wrong spacing or having invalid YAML syntax that's going to break Ansible. So that the first major change I make is I put a lint section in. You can see after dependency and driver, I have a lint section. And in the lint section, I just basically write a little shell script. And that shell script does set-e to make sure that it fails if there's a failure. And then I run YAML lint, and then I run Ansible lint. Then the next section for platforms, I change it up a little bit. Since I often am testing things that run a service, and the service requires systemd, I have it run a custom Docker image that I create. I actually have a set of Docker images. I have CentOS 6, 7, and 8, Ubuntu 14, 16, 18, and 20, Fedora 27, 28, 29, 30, 31. I have basically all the major modern versions of any distribution. I have a Docker image like this. And the Docker image already includes systemd out of the box, so that I can test with services like install Apache and run it inside the container instead of starting the container with Apache. This way I can test my playbook inside of it. But to do that, to make systemd work inside the container, I also make a couple other changes. You can see I add a volume that shares the C group inside the container. I set the privileged flag to true and pre-build image true. That just tells Molecule that this image needs to be run with those kind of flags, and it already has all the things inside of it that it needs to run these tests. And then finally, there's the provisioner and verifier. I'm using Ansible, that's the defaults, but I like being explicit about it. What Molecule is going to do is it's going to take all this information, and it's going to use its Docker driver to create an instance inside of Docker, just one container that has all this stuff in it. It's going to copy the playbook in that I'm going to run, and then it's going to use Ansible to run the playbook inside the container and make sure it works. And then it's also going to, if there's any kind of verification playbook that's in the Molecule directory, it's going to run that verification using Ansible as well, which is nice because I like just writing Ansible to make sure that my Ansible is working. Sometimes you don't even need to do extra verification because you can do it inline using debug module or assert or fail or different modules like that. But that's a topic for a different day. For now, this is how we're going to define our Molecule layout. The next thing is we need a playbook for Molecule called converge.yaml. This is going to run whatever the automation is that we're testing, basically. So in our case, we have the main.yaml playbook that I showed earlier that installs Apache, copies a web page, and makes sure Apache is running. And that playbook is up to directory. So the playbook is in the main folder for our project. And then right now, the converge playbook is in molecule/default/converge. So to import that playbook, I need to go up to directory level. So .. / .. and then main.yaml is where the playbook is. So that's a pretty simple file. If you needed to do any special preparation inside of the Molecule environment that it sets up, you could do that here. But typically there's other places to do that. But in our case, we don't need to do anything special. The next different playbook that we're going to add is a verification playbook called verify.yaml. So alongside the molecule.yaml and the converge.yaml, we have a verify.yaml. And I'm just going to have one task in that playbook, and that task is going to load localhost. So if Apache is not serving web requests properly, then this is going to fail. We're going to get a 400 or 500, or we're not going to get a response. And because of that, this task would fail if it can't load the page. So we're going to load it, and we're going to expect a 200 response, meaning Apache is serving the page correctly and giving an HTTP 200 OK message. So we have the Molecule configuration done, we have the Converge playbook done, and we have a task that's going to verify that everything is working at the end. And the next step is to actually run the thing. So I have a screen recording here that I'll narrate a little bit while it's going. And this screen recording is going to show what happens when you run Molecule test. There's actually a lot of different commands you can run besides Molecule test, but I'll describe it first. Molecule test does a series of predefined tasks like install any dependencies if you have dependencies on Ansible Galaxy or Automation Hub. It's going to run the linter to lint your code and make sure that it's all correct and the syntax is correct. And if any of these things fails, it stops and it resets your environment. Once all the prerequisites are done, it sets up an environment, which it did a little bit earlier. It creates that Docker container. Then it runs the playbook, which you're seeing on the screen right now. And then it runs it again using the idempotent test to make sure that everything is still working and no changes were made. Then it runs the verifier, which it just did. And then once it's done and it makes sure that everything is working correctly, it cleans up the environment, it deletes that Docker container. And now if you have no errors, then that means everything tested well. With Molecule, there's other ways when you're locally working with it. You can run Molecule Converge to bring up the environment and run your Converge playbook, and then it's going to leave it alone, which is cool because that way you can bring up the environment and then log into it using Molecule Login. And you can go around and explore it. If there's an error, you can explore why did this error happen. You can check things and then run Molecule Converge again to make changes or to see things or to debug problems. And then if you ran Molecule Converge and it's still running, you can always run Molecule Destroy to destroy the environment. Molecule Test is great for CI though because it's completely self-contained. It runs and then it stops and cleans up after itself. And if there's any errors, it'll stop and clean up after itself. So that's what we are going to use when we go into GitHub Actions. So we're going to integrate Molecule, the little configuration that we just made, that tests this playbook and makes sure it's working correctly with GitHub Actions. And what is GitHub Actions? GitHub Actions, just a quick overview, is the ability to add a workflow to any project that's on GitHub. And there's a lot of different systems for this. I'm talking about GitHub Actions here in this presentation, but I know that GitLab has their CI, and there's other tools like Circle CI and Drone, and you could even integrate Jenkins with projects. All these different things can be used as CI systems, but GitHub Actions is great for me because all my projects are hosted on GitHub already, and all I have to do to integrate my playbooks or any projects with GitHub Actions is create a workflows directory and create a workflow in that directory. So those are the two steps in this slide. The first thing is, in any project that's on GitHub, you can create a workflows directory inside a .github directory. So that first command is making that directory .github/workflows. And then the second step is to create a CI.yaml, or you can name it something else, but I like naming my continuous integration workflows that run all my tests CI.yaml. So I'm touching a file in there, CI.yaml, and I'm going to put this into it. Now, this is YAML as well, and GitHub Actions actually uses a syntax that's a little similar to Ansible. It's a little different, but once you get further into some of these workflows and customize them more, you realize just how much the same they are, just with a little different terminology. So the first thing is you have to define a name for the workflow. That's the simplest level, is it just needs any name, and this will be the human readable name. So I just usually call mine CI, but you could call it continuous integration or integration tests or whatever you want to call it. That'll show up in the interface later when we run this thing. And then you also define when it's going to run. So there's actually a very complex syntax of different ways you can control when the CI stuff runs. In my case, I just want it to run on any push to the master branch because that's the main branch on my project that I want to make sure that is always working. So anytime code is pushed to it or there's a merge to it, I want to make sure that it's working. And I also want it to run on all pull requests. So if somebody submits a pull request to my project, it's going to run the CI workflow. And then we define a series of jobs. In my case, I'm just going to run one job, but you could have more than one job run. In my case, I'm just going to run this test job, and I'm going to call it Molecule. That way in the interface, when I see the CI workflows running, it'll show that I'm running Molecule. And then we're going to tell it what type of operating system to run on. There's a few different options, but I usually use Ubuntu latest, which is right now Ubuntu 20.04, but will be whatever the latest version is of Ubuntu. Then you give the steps that the job will run. So once it builds an Ubuntu test environment, there are things called GitHub Actions. Like the first one here is checkout at version 2. So this just checks out the code into the test environment. And then there's an action called setup Python. That's going to set up Python for me. Otherwise, I could do this all manually, but using these actions just makes it a little quicker and easier. And then I'm going to use the run command or module or whatever GitHub calls these different things you can do. And run lets me run any arbitrary command. So I'm just going to run the command pip3 install Molecule, YAMLint, and AnsibleLint, because those are the three dependencies I could also put Ansible in this list, but when I install Molecule, it's also going to install Ansible for me. So I don't need to be explicit about that. And then the final task is going to finally run Molecule test, which we just did a few minutes ago. And Molecule test is going to do all the same things. It's going to test for idempotence. It's going to make sure the playbook runs. It's going to lint it. There's two special things in here that we didn't have to do locally. When you run Molecule with a TTY, or in your terminal where you're interacting with the terminal, all the colors come through appropriately. But if you run it in CI, in most CI environments like Jenkins or GitHub Actions or Travis CI, Circle Drone, whatever, it's not going to show colors, and that makes it a little harder to read through the output. So if there's an error message, it should be red, but if you don't have a TTY, if you're not interacting with your shell, it's just all going to be black and white, and it's hard to tell what's going on that way. So I add two environment variables whenever I run Molecule commands in CI. The first one is pi_colors, and I set that value to 1. That's going to tell Molecule to use colorized output even though there's no interactive terminal session going on. And then the second one is Ansible_force_color. That tells Ansible to output colors even though there's no interactive shell. So let's go ahead and commit this file to our project that's on GitHub. This file again is going to be in .github/workflows, and I named it ci.yaml. And once you commit this file and push it up to GitHub, as long as you haven't disabled manually actions on your repository, this will actually kick off the first actions run. And let's see how that looks. I created this little GitHub project for this presentation, AnsibleFest Virtual 2020, and I committed and pushed the file. And now you can see that it runs. There's a CI workflow, and if I click on Molecule, it takes me right into the job output, the terminal output, and you can follow the progress of it as it goes. And there's a couple other things I'm not showing too much in this particular screenshot. One thing is you can dump the raw log files out to a text file. Sometimes that's helpful if you have a really long playbook or you're running the playbook in debug mode. You can run Molecule --debug test. That outputs all kinds of information about every task, but it's a lot of information. You can download the raw log files from GitHub Actions so that you can parse them out a little bit easier. You can also grab a badge. So this workflow just finished, and now there's a green check mark, and that's cool to see that green check mark. That means things are good. When you see things not like the green check mark, then you know things are bad, and you got to fix something. Or sometimes something just broke, and you run it again, and it works. If you go to the workflows, you can actually click on an option, and I don't remember exactly where it is. Sometimes I forget where it is when I'm even clicking around in there. You can get a badge for the status of the workflow, and you can paste that badge into the README file so that when somebody comes to your repository, they can see right at the top that it's passing CI, and they can click on it if you add a link to it, and they can click on and go through to watch your CI in action. And what I didn't do in this particular workflow file, so I'm going to go back over to the workflow file. I didn't add a schedule, but typically for my projects that I care about a lot more, I'll add a schedule under the on section. And the schedule allows me to tell it to run daily or weekly or monthly. It depends on how active I am developing a project. If I'm very active and it's an important project to me, I usually run it daily, sometime between 1 and 5 a.m. US Central Time. But you can set any kind of schedule. For some of my projects, I just have them run once a month, and every now and then one of them fails, and I'm like, oh, what's that? And then you see that there's a dependency that needs updating, or there's something that changed in Ansible that makes it need an update, and I make that fix, and the project keeps working. So that is GitHub Actions, and as I said before, that whole example, actually a little bit more detail than that example, is available in the repository for this book. So there's the complete link to it. It's on GitHub in my account under the Ansible for DevOps project. And like I said, chapter 13 of the book is where you can find every little detail about it. And I also have an Ansible 101 series on YouTube. If you just search for Ansible 101 on youtube.com, you'll find it. And in that series, I also cover a Molecule a bit more in depth, and also continuous integration in a bit more depth. Unfortunately, because of the 30-minute session, I didn't have the amount of time that I had in those cases to convey all of the wonderful things that I have learned about CI. So with all that, I'm going to conclude this with some haiku, some DevOps haiku. It's impossible to maintain many projects without good CI. And I would say not only for me, but for whatever business you work with, if you're going to maintain things and maintain them well, nowadays everybody seems to be maintaining a lot of projects, whereas in the old days it might have been 1 or 2 or 3. Nowadays it's 10 or 20 or 500. And it's very hard to maintain many projects and have them keep working without good CI integration. So hopefully this presentation helped you. Thank you for watching, and I would love to hear from any questions you have, and also feel free to connect with me on Twitter or LinkedIn or wherever you are present. I'm Geerling Guy pretty much everywhere.